In section 2.4, we're going to continue looking at polynomials, and in particular looking at their zeros. And we're going to get some theorems that are going to make it a little bit easier for us to find them in a lot of circumstances. Just a heads up, I'm going to present the material in a slightly different order from your textbook. Shouldn't be a big deal, but just wanted to acknowledge that. So I'm going to start with the conjugate pairs theorem. That says this: if f of x is a polynomial with real coefficients, so that just means that imaginary number I doesn't show up at all in the coefficients of my polynomial. Okay. And then if I have a plus bi, where b isn't 0, is a 0 of f. That just means that this is complex and not real. It's not enough for me to say that it's a complex 0, because real numbers are part of the complex numbers. So I need to specify that this is not real, and I do that by saying that the imaginary part is not 0. Okay. So if I have a complex non-real 0 of f, then its complex conjugate is also a 0 of f. Remember, the conjugate would just be a minus bi. Same real part, opposite imaginary part. So, as a simple example, if I is a 0 of a polynomial that has real coefficients, negative I would also be a 0. If 3 minus 2i is a 0 of a polynomial with real coefficients, 3 plus 2i, just change the sign of the imaginary part, is also going to be a 0. Okay, now that shouldn't come as too big of a surprise, because whenever we've had non-real zeros, they have come in pairs like this, and that's because we've generally gotten them by using the quadratic formula. And when we use the quadratic formula, we get x is the opposite of b plus or minus the square root b squared minus 4ac all over 2a. When this part under the radical is negative, then we get complex non-real numbers, and you can see right there we're getting the conjugate pairs. Something that's also true but not explicitly stated in your textbook is that if the coefficients are rational, now rational, we'll be talking about a little bit more in a second, has the word ratio in it. That just means that this can be written as a ratio or a fraction of integers. Okay, so all the integers count, because 2, for example, could be written as 2 over 1, and then we get all of the fractions. What we don't get is the roots that don't simplify. So if the coefficients are rational, irrational zeros also come in conjugate pairs. So that would just mean that if the square root of 2 was a 0 of a polynomial with rational coefficients, negative root 2 would also be a 0. If 3 plus 2 root 5 was a 0, 3 minus 2 root 5 would also be a 0. And again, for the same reason, that would just mean that we got a root that didn't fully simplify from the quadratic formula, but the quadratic formula is always going to give me pairs of zeros. Okay, so how does this help us out? Well, what I'm going to do is give us a polynomial. I've actually taken one from an even-numbered problem in your book, but I'm going to change the directions slightly. The polynomial is x to the 4th plus 6x cubed, minus 6x cubed plus 5x squared plus 30x minus 50. And I'm going to tell you that 3 minus I is a 0. Okay. And what I want to do is 4 things. Okay. I want to first of all find all the real zeros. Then I want to find all the complex zeros. Now, that will include all of the real ones. Okay. So here I could just as easily have just said find all the zeros. Okay. Your textbook isn't generally going to ask you to distinguish, and in this section most of the directions are just going to say find all the zeros. Unless otherwise specified, that's all complex zeros. But I want you to be aware of which ones are real and which ones aren't, and also to be aware that the real ones are included in the complex numbers. So I'm going to have you distinguish them here. And then I want you to factor completely over the real numbers. And then I want you to factor completely over the complex numbers. Okay. All right. So I've actually got to start here. I was told that 3 minus I was a 0. And by the conjugate pairs theorem, I know that 3 plus I is also a 0. Those are not real, so I'm going to list them right here. Of course, once I have zeros, I have corresponding factors. Now, I could do synthetic division twice, once with 3 minus I and once with 3 plus I to factor this over the complex numbers. I think it's actually easier when you're dealing with non-real zeros not to use the synthetic division. I'm just going to say I know that x minus 3 minus I is the factor that corresponds to that 0, and x minus 3 plus I would be the factor that corresponds to that 0. I'm going to simplify this because I can distribute that negative. So we'll have x minus 3 plus I. And then this, I'm just going to write below it so that I can use the vertical format for multiplying that out. That would be x minus 3 minus I. I'm going to go ahead and write in those factors. Those are factors in the complex numbers, x minus 3 plus I and x minus 3 minus I. Not going to list them as factors in the real numbers because they've got imaginary numbers in them. Okay, if I multiply this out, you know what, actually I think I'm going to copy it over here where I've got a little bit more space. So x minus 3 plus I, x minus 3 minus I. Okay, so remember, I'm just going to distribute these terms one at a time. So negative I times I is going to give me a negative I squared. Negative I times negative 3 is plus 3i. Negative I times x is negative ix. Negative 3 times I is negative 3i. I'll line that up with the other imaginary numbers. Negative 3 times negative 3 is positive 9. I'm lining that up with the other real numbers. Remember, even though I is imaginary, I squared is real because I squared is negative 1. Okay. And then negative 3 times x. I'll create a new column here. This is where I'm listing imaginary x's. Here I'll put my real x's. Let's distribute the x. X times I will give me ix. X times negative 3 will give me negative 3x. X times x will give me x squared. All right, so I get x squared minus 6x. Notice the imaginary x's and the imaginary i's cancel. Negative I squared would actually be positive 1 because it's the opposite of negative 1, so this is plus 10. Okay. Now, there's a built-in check here. If you multiplied out the factors corresponding to complex conjugates, you should get something completely real. I'm going to go ahead and list this, x squared minus 6x plus 10, as a factor in the real numbers. That has real coefficients. That's equivalent to these two factors in the complex numbers. Over the reals, we would say this is irreducible. It doesn't factor anymore. But over the complex numbers, we can break it down into two linear factors. Okay, so now, how does that help me? Well, I basically know that f of x is x squared minus 6x plus 10 times some other factor, which I would like to know. If I want to find this factor, I'm going to get that by dividing this over. So that would just be f of x divided by x squared minus 6x plus 10. So for that, I'm going to have to do long division because this is a quadratic that I'm dividing by. So we've got x to the 4th minus 6x cubed plus 5x squared. I'm sorry, that should have been plus 30x, I think. Yes. Sorry, plus 30x minus 50. And I'm going to divide that by x squared minus 6x plus 10. Okay, so I look at my lead terms. What would I multiply x squared by to get x to the fourth? I'm thinking x squared. So x squared times x squared will give me x to the fourth. X squared times negative 6x will give me negative 6x cubed. And x squared times 10 will give me 10x squared. So now we're ready to subtract. Remember, that means we change the sign and add. So the x to the fourths cancel. The x cubeds actually also cancel. 5x squared minus 10x squared will be minus 5x squared. And I'm going to bring down the next two terms since the first two canceled here. So plus 30x minus 50. And we repeat. So what would I multiply x squared by to get negative 5x squared? I'm thinking negative 5. Negative 5 times x squared will give me negative 5x squared. Negative 5 times negative 6x will give me positive 30x. And negative 5 times 10 will give me negative 50. Notice that's a perfect match so that when I change the sign and add, everything cancels out. Okay. So I now know that my second factor in the reals is x squared minus 5. So we've got f of x is x squared minus 6x plus 10 times x squared minus 5. Okay. Now, I can now factor that further. That's going to factor as x minus root 5 times x plus root 5. Now, usually when I'm factoring, I just work over the integers, but here I can see that root 5 and negative root 5 are going to be zeros of this. If you see that right off the bat, great. If not, we'd be looking for the zeros. What makes x squared minus 5 equal to 0? Well, that would mean x squared would equal 5. X would be plus or minus the square root of 5. Do remember that there are two answers here. Okay. If I'm working in the reals, I would take the square root of x squared and just say it's the absolute value of x. And I could certainly do that here because root 5 is a real number. There are no i's in it at all. But because in this section we are going to be working in the complex numbers, I'm going to avoid that. I'm going to just say take the positive or negative square root of both sides. That's because the notion of absolute value makes sense for real numbers, but it's not defined in the same way for complex numbers. So when I get something like this, I'm just going to go right to plus or minus the square root of both sides. And if there's a plus or minus here and a plus or minus here, I mean, I could technically say plus or minus x is plus or minus 5, but there are really just two possibilities. Either they have the same sign or they have the opposite sign. Okay. All right. So these are irrational, but they are still real. So I found two real zeros, root 5 and negative root 5. The real zeros are also complex, so I'm going to add in root 5 and negative root 5. And then these are the corresponding factors. Now again, you might have seen that you could factor that right off the bat. You might have gotten that by finding the zeros first. And you've got a couple of options for finding the zeros. Here I did it by taking plus or minus the square root. You could have also used the quadratic formula. Okay, so x minus root 5 and x plus root 5, those are real factors. So over the reals, we get three factors, two linear factors and one quadratic. And then over the complex, we get four linear factors. All right, excellent.